For the coffee question, A, the initial amount, would be 130 milligrams. The rate at which coffee is eliminated is 11%. For math formulas, we'll use decimals, which would be 0.11. For the time, question is how long it will take. That will actually be our variable. We can use x or t. Y will be the final amount. We want half the caffeine to be eliminated. So if our initial amount is 130, half of 130 would be 65. Plugging the numbers into the formula, y equals a parentheses 1 minus r to the t power. Y would be 65. The initial amount would be 130. The rate would be 0.11. And the time is what we're solving for, which we'll use the variable x. To solve this, we can first divide by 130 on both sides. 65 over 130 would reduce to 1/2. 1 minus 0.11 would be 0.89 to the x power. Again, when we have variables as an exponent, that's when we can use logarithms to solve it. Next step, I'll switch around the equation. I'll put 0.89x on the left side and 1/2 on the right side. This way it's in the standard form that we've been solving the previous questions. Again, to solve exponential equations, we can switch them to log equations. 0.89 would be the base, and x and 1/2 would switch sides. So we'd have log 1/2 base 0.89 equals x. All answers in log, again, should be in standard form or base 10. So using our change of base, this would be log 1/2 divided by log 0.89 equals x. If you wanted to, you could change this to 0.5, or we could change this decimal to 89 over 100, but it's okay to have fractions inside of logs. If you use a calculator, the answer would be 5.9480, which, looking back at the question, how long will it take for half the caffeine to be eliminated? In terms of hours, it'd be about 6 hours to eliminate half the caffeine. The half-life of carbon-14 is 5,760 years. What is the value of K? By definition, half-life is a substance, which in this case 5,760 years, half of that substance disappears. In terms of exponential decay or growth, this would be decay because half-life, your life is decreasing after 5,760 years. So the equation for decay we'll be using y equals a times e to the negative kt power. For variables, a, the initial amount. The problem does not state the initial amount, but since we're using half-life, we can pick any number that we want. Nice easy number that we can take half of would be 2. K is the constant. That's what we're going to be solving for. T is the time. Time for the half-life in this case is 5,760 years. And y is the final amount. If we started with 2, half-life, again, half of it disappears after 5,760 years, so half of 2 would be 1. Plugging these three numbers in, we can solve for k. Y is equal to 1, a is equal to 2, E again is a constant from natural logs. We have negative k times t. T is 5,760. And k again is what we'll be solving for the constant. First step, you can divide by 2. And we'll have 1/2 equals e to the negative 5,760k. Same steps as before. I'll rewrite this equation with e on the left hand side. 5,760k equals 1/2. And again, with a variable in the exponent, we can use logs. In this case, whenever we have e, we want to use natural log, ln. The ln again would be the base, e. We can leave that off or write it there. And just like before, the other two numbers would switch sides. This would become the natural log of 1/2 equals negative 5,760k. To solve for k, we can divide. And our final answer, natural log of 1/2 divided by negative 5,760 is what k is equal to. Using a calculator, you can get a decimal for this. That decimal would be 0.00012. K again is just a constant. That constant would be the same for any problem dealing with the specific carbon-14 and half-life. For this question, we're given the equation y equals 1.31 e to 0.0038 t. And we want to find out the population in 2009. T is the time after 2005, so 2009 would be 4 years later, so t would be equal to 4. Multiplying 0.0038 times 4, that would be 0.0152, and we'd still have, the t would be gone because we're plugging a 4 in. This would be your final answer without a calculator. If you had a calculator, you can use the E button to find out this decimal, multiply by 1.31, and that actually comes out to 1.33. In this problem, China started with 1.31 billion people in 2005. 4 years later, in 2009, they had 1.33 billion people.